So, as always, the code for this question will be in the description, but if you want the explanation and the intuition, you can continue watching this video. Now, see, I'm usually a code courses guy, but one of my friends suggested me this question, and he said it is difficult. It's very difficult. It's a rating of 1900. Difficult, my fucking ass. Okay, I'll tell you how to solve this thing in the easiest way possible. Okay, look at this thing properly. What is this? You're given two elements, no, two numbers A and B. Right? Simple. You'll be given a number, for example, let's take some small number 2 and 1. Now, what do we have to do with these two numbers? First, find number x. What is x? X is a number which, when done this operation, will give a number which is minimum possible. That's basically the question. But see, I'll tell you one thing. This is really simple actually. If you break it down to its most essential component, as I told you, as I keep telling you. Now, how to break this thing down to its most essential components? We need to find x such that this value will be minimum. And this is XOR. And this is the modulus, absolute value, which means that if it is negative in any case, then it will become, this will make it positive. So with this thing, okay, this is simple. We need to find x such that it is there. And there will be multiple possibilities for the x, and you need to print, you can print any one of them. Now, think about this thing properly. What are we supposed to find? X. No, I'm not joking, seriously. We are supposed to find x. What is x? The x will be such that if this number will be minimum. Okay, what is this thing? Now we'll remove the outside thing, which is the absolute value. What we'll get is this. We'll get this value. So if we remove the absolute value, what we'll basically get is, we need to find the absolute difference between these two numbers. Let's forget about this thing, take these two as two numbers. To find the absolute difference between these two numbers, right? Basically means that, see, the thing is 101 has a difference of 99, but 1 and 2 has a difference of 1, right? So when you take it as an absolute value, no matter what number is higher or lower, the closer two numbers are together, the closer two numbers are to each other, the less the value will be. We need the minimum value, right? So the closer you bring these numbers, the minimum you will get. But how can you do that? Can you do that thing? Because that is how you will get the minimum value. But can you bring these two numbers closer in such a way the difference will be minimum possible? Turns out that's where they helped us. If we open these two, we'll get what will we get? Let's analyze one at a time because the other is not necessary. Okay. A XOR X. So what they have basically given is this XOR, right? XOR truth table, if you don't know, if you don't know, first things first, Google it, okay? I'm not going to write everything on the board. The first thing, but I'll explain to you. Basically, if one is 1 and another is 0, that will give you 1. If both are zeros and both are 1s, it will give you 0. Which means that it's basically like OR, except for if both are 1s, that will be 0. That's it, okay? Check Google if you want it properly, okay? So, we can XOR A with X, okay? Now, I'll tell you how is this thing going to help us bring these two elements, these two numbers closer together. I'll tell you how. And have a mental note that this X is also in B, the same X is also in B. Take 2 and 1 is kind of bland, okay? It's really bland actually. I hate this example as I keep talking. So I'll take 15 and 0. Nice number, it's also in the test case, the final one, which is the actual test case that matters. The rest of them you'll get different answers, only that one maybe you'll get, no, even that you'll get different in my algorithm. In yours maybe you'll get a similar one. If that's the case, do your own algorithm, okay? Don't watch this video. 15. What is the binary representation of 15? Right? 1 plus 2, 3 plus 4, 7 7 plus 8 is 15. So yeah, I'll write it down to 1, 2, 4, 8. Okay, so this is A and B is 0. So basically it's basically 0. That's it. That's B. This is A and B. Now let's put B aside, I told you, but I just wrote it down so that I can open this thing too and it will be ready. Now A XOR X. What does XOR mean? Basically means that if we have 1 over here for X value, if X value is 1 in this particular case, then A XOR X will give us 0. So this basically means that with XOR what we are able to do is convert this number in such a way that it will decrease. That's what we're doing, right? And we can increase it too. We can increase it if A is 0 somewhere over here. For example, if it's 0 and we add X1 over there, it will become 1. So with XOR, now we have the potential possibility to increase or decrease a number A and B, which basically means that we now have possibility to bring these two numbers by increasing this value and decreasing this value. And that's how we get the minimum difference, right? See, the thing is, XOR is, this is not a hard question because everything is set in such a way that it will become easy for you. Basically means this XOR function allows us to basically now manipulate A and B in such a way that we can bring one number higher and other number lower, such that the difference now is smaller. Now, how do we do it? That's the question. Now we know how to do this thing. XOR will help us with that, but how do we do that? Another point to mention is B XOR X is also there. So X will also be XORed with B. The same number will also be XORed with both A and B. Do you think this may be a hindrance? No. It's actually a good thing. This will make this thing even more easier. I'll tell you how. Now let's open this thing now. Keep these two as separate still. Because keep these two as separate. But I open this thing, which means now I'm going to explain this thing too. And it's 0 here, right? What will happen if I XOR 0 with 1? It will become 1. Which basically means that if X is 1, what will happen is this B will become 1. A will become 0 and B will become 1. This is really important here because what I just told you is basically the answer. That's it. This is the answer. This difference, if you take this thing, will be the minimum. And the value of X is 1. That's the answer. Okay. But okay, let's not get ahead of ourselves. I'll explain to you what just happened. What basically happened is I've taken X as 1. Then if the numbers are opposite, what will happen is basically the numbers are opposite is not the point here, but if it is opposite, this will become 0 and this will become 1, right? That's what happened. It was 1 and 0 here, now it's 0 and 1. You can think of it as this way. If X is 1, then this values will interchange. Or in another way, what this basically represents is A will give a part of its number value to B. Now A consists of this, 15 consists of 8 plus 4 plus 2 plus 1, right? So B consists of 0, nothing. So A will give off its 1, a part of what makes it 15 to B, which means that 15 will become 14. 15 will become 14. 15 will become 14. Sorry, it will become 14. Give 1 off to B. Now the difference is 14 minus 1. Before it is 15 minus 0, which is 15. Now it's 14 minus 1, which is 13. See, the thing is, now you call both those numbers closer. What did you do now? What you did before, the same thing. You keep adding 1 again, so that what will happen is, this will give away its 1 to this B and will become 0. Now what is the thing? It will be 3, 12, right? 8 plus 4 is 12. So 12 minus 3, which is 9. The difference is even smaller now. So basically keep doing that thing till we get this. we give away the last 0, the last 1 to B with x1. With this, what we have done is, we have the minimum possible difference because 4 plus 2 plus 1 is 7 and this is 8. So B is 7 and A is 8 now. We have brought them down to such a level that now it's 7 and this is 8. Now if you try to put this 1 here, the problem we'll get is, so the thing is, this graph of how low it will get will be like this, something like this. This is how we'll get it, basically. It's not till here, but this basically means that the difference, as we keep giving 1 away to the smaller element, the difference will keep decreasing. Before it was very high, the difference will keep decreasing. It will never approach, maybe it will approach 0 at some point, but it won't, maybe it won't. The graph is not for this one, but let's say this is 1, okay. It will keep decreasing. After I give 8 away to B, what will happen is, it will become 15 and 0. There will be a sharp increase. So what will happen here? Basically the graph had to draw it properly is, it will keep decreasing till it's 1 and then it will go back to the same position. That's it. So at this point what will happen is, if you keep adding 1 for x further, it will just keep adding, won't actually change it a lot. Okay. This will be the graph for this thing. This is the point we need. Basically the thing is, in this case, how do we know when we reach this point? We'll know that when this value, the value of 1 here is 8, right? If this value is greater than the difference between these two numbers, in this case it is 8 minus 7 is 1. So 8 is greater than 1. So at that point we know that if we give 8 away to B, the difference we'll get won't it will be greater than the difference now, which is 1. So now the minimum difference is 1. Basically what to understand from this thing is, we can use x. How we can think of x is, if x is 1, then the bigger element should give away its 1 to the smaller element. There are small points here, small like edge cases, which is that what if both of them are 1s? The thing is, all well and good, but imagine let's forget about x. Let's say we didn't write x at all. This is the value. Let's take it like this. Okay. Now this is the value. See, anyway, if you keep 1 or 0, these both of them will be affected, and both the ones will be cancelled out when you subtract these two. You have to subtract these, right? So both of them will be cancelled anyway. You don't have to worry about these things. If the smaller value will have 1 in the position where the larger value also has a 1, it will become 0, x will be 0. But if in this case, for example, here it's not there, but I'll write it down. If it is 1 here, if there is 1 here, then we'll add it to 1. B, we'll have the current difference, we'll add this thing to B, and we'll check the difference again. It will obviously be lesser, I mean the difference will obviously be smaller. And we'll keep doing that till we get this value, the minimum value, which means that till we get that, here it's 8, right? As I told you, 8 minus 7, the difference we had before was 1. Now if we check if this value 8 is greater than 1, yes it is. At this point it's no longer feasible to go any further and check whether it is, will get a small difference or not. It's not possible. Not possible. It's not only possible, not even necessary to go further. So basically what this means is, okay, I have said basically a lot of times, but given A and B, take the bigger number. I'll tell you the entire thing. Given A and B, take the bigger number. As long as you find the bigger number, as long as the smaller number does not have 1 and the bigger number does, give it away to the smaller one. Start with the smaller ones. Start with 1 and 2, not from 8 to 1. Start with 1 to 8. Give away the numbers. Check the difference. If it is smaller, the difference is smaller than the previous difference we had, update the smaller difference, and you do the same thing till the difference between the values, the two values, which is the difference between the previous one, the smaller difference you got, is less, greater than this value. Till you get that thing, you keep doing it. And one thing is, at some point the difference will keep increasing if you don't do that thing. If you don't want to do it, in the code I didn't do that thing. What I did was, if you go further, okay, you still keep finding the difference, you still do it, the difference will be greater. At that point you can break away. At that point you can break away from the array, from the while loop, because it's like, at this point it's no longer feasible. You can just break away because the difference you're getting is increasing. The graph I told you, right? So this is the point we found difference. For that we found the x, which is supposed to update the x only when the difference is smaller than the previous one. Update the x only when the difference is smaller than the previous one. You add that value to it. So with this one, once you get out of the loop, you can just print x and you get the value. See, as I told you, the code is actually pretty simple. The intuition was really simple. You just have to keep this thing in mind and you'll get it. So I'll get to the code now. I'll explain to you the code. It's also really simple. So yeah, that's it. I'll get to the code now. Yeah, so as you look at, if you look at this code, it's the same thing. You have A and B, and one thing is, I forgot to mention in edge case is, if A is equals to B, what will basically happen is, since A is B, the difference is already 0. So you can't get any lower than 0. So x is 0 will also be sufficient for this case. So as long as A is equals to B, you can print 0. Else, then you can go further to this code. This is the actual code. This is an edge case. It simply can print 0 if it is A is equals to B. Else, let's take x as 0. Initially, as always, x will always be 0, right? Now we'll take the minimum and the maximum value. Since we want to take the maximum value, we'll keep removing the values from it and giving it to the minimum value. So we'll take the minimum and maximum value. And now, this is an important part here, the code explanation, which is binary max and binary min, which basically means that the binary representation of the max and min values. But in this case, the binary function for Python will give us in the string, the starting string, it will give us something like 0, b and some, then we'll get the actual value. So if we start from 2, we'll get the actual binary value. And what is this for? See, the thing is, if we look at this thing really carefully, in the binary value will start from the right side, right? The 1 value will start from the right side and 2 value will start from the second most right side. So -1 value, -2 values as that. So if we reverse the string, what we'll get is the indices will be aligned with the numbers, which means that, for example, take the binary value is 0 and 1. If it is 0 and 1, no, if it is 1 and 0, sorry. So 1 and 0, it's 2 basically, right? We know that. But if we reverse this thing in the array, what we'll get is we'll get 0 and 1. Right? We'll get 0 and 1. And 0 will be in the 0th index. And 1 will be in the first index. What we can do is 2 power 0, 2 power the index of this array, which is 2 power 0, into the value of this thing, which is 0. And is 0 plus 2 power 1 into 1, which is 2. So if you look at that thing, if you go that way, you will realize that as you keep multiplying it to the, as you keep powering it to the index, 2 power the index, specific index we have, into whether it is 1 or 0, we'll get the value at that particular point. And that's what we're doing, right? We keep incrementing the value, the pointer, and you keep giving away the values. If you want to know what the value is, this will be convenient ways. It's basically for convenience, that's it. And then the previous difference and new difference, we'll have two variables. Previous difference will be the maximum value. The new difference will be the difference between these two values, which you will get. An iteration, we'll start with the while loop iteration as long as iteration is less than length of this value, binary max. Now, this if condition is a small edge case too. The thing is, I told you that if in the minimum, in the smaller value, if there is a 1, then you don't need to actually keep x as 1 in that position, because if both are 1, even if it is a small, if the upper one is 0, the lower one you don't want to remove anything from it, because the lower one, the small value, we need to keep increasing it, right? So if either the iteration is less than length of binary minimum and binary minimum of iteration is 1. if these two conditions are satisfied, which means that yes, it is still, the pointer is still able to point out the binary minimum, since because like binary minimum could have like 4 values and binary maximum can have 6 values. So as long as it is in the range of 4 and the iteration, the binary minimum element in the iteration is 1, if it is 1, then we can continue, you can just iterate the next value and we can continue. This is the main code. The thing is, if no, it's not the case and we don't have that, in that smaller value it is 0 and in the bigger value if it is 1, the 1 and new difference is greater than value, greater than or equals to value, then what we are supposed to do is max val will be decrement, we will decrease that thing and we will give it away to this one. Now we will calculate the new difference, which is this one. Now if new difference is less than previous difference, we will increment x with that value at that position, and then previous difference will become new difference. If that is not the case, we will break it, because if I told you right, if it's not the case, if this is not the case, then it's no longer any point to check any further, because we found the minimum value. And the minimum value x also we found it. We only have to update x if the value is lesser, the new difference is lesser than the previous difference. Only then we'll update the value of x. We'll keep adding it. Will not x won't be equals to value. X will be added with the value. So for example, in the case I told you, 50 and 0, we'll add first 1 to x, then we'll add 2 to x, then we'll add 4 to x. So that we'll get 7. So x value is what we need to print, so we'll keep adding x with the value. Now, if else we'll break it, and iteration will keep it at 1 plus 1. If this is the case, then we'll iterate to the next one and keep checking it, right? Else, no, if this is also not the case, then we'll iterate with plus 1. Actually, this is not necessary, but I written the code in such a way. So we'll print the x value. So basically what you're doing is, it's a pretty simple thing. You do all these things. First you need to check the binary values, you need to keep it according to the array. Then we need to iterate to each and every value and check whether the difference is less than, new difference is greater than or equals to value, and then we'll give that value from max to min, and then we'll check whether the new difference is less than previous difference, and we'll add x to it, and if not, we'll break it and we'll print x. That's it. The thing is, it's a pretty easy question. I don't know why my friend told me it was difficult. I mean, this just goes to show that it's actually easier to do most questions in other platforms rather than code forces. So that's the reason it's not a code forces question. I think so. Or maybe I'm being too cocky or arrogant. So yeah, that's the explanation. If you have any other more doubts, you can leave in the description. I don't think anyone is going to write that thing, but yeah. So thank you.